Hello, my name is Walter Unglob, and this is how to find x and y on special segments. So here I have a circle of radius r, and I have a special segment, which is essentially just this chord that I've placed on the xy plane, where it meets up with the circle at this point and crosses through at some angle theta and leaves the circle at this point. So there are two commonly shared points between the special segment and the circle. And what we're interested in is trying to relate the two equations. So for the circle, of course, we'll have x squared plus y squared is equal to r squared, where r is some parameter and some constant, and x and y are variables. And for the line, we can write the slope-intercept form, which is y is equal to mx plus b. So if we knew this height, h, for example, and this distance, let's call it a, then we could calculate what the slope is. So m would be equal to the change in y divided the change in x, and that would simply be h over r plus a, and this would be equivalent to tangent of the angle theta. So, if we know the slope then, and we know one of the data points, we can actually calculate what this y-intercept denoted b would be. So what we have then is, if this is true, then we have delta y is equal to m times delta x. The change in x would actually be r, the radius. So this delta y, the change in height, would simply be m times r. So therefore, we could simplify this into mx plus mr, and we would get y is equal to m times x plus r. And this equation would relate x and y given a slope m, which one could calculate, given some other parameters, and it would be dependent on the radius r of the circle. So given one point, you can find another point along the line. My name is Walter Unglob, and this is how to find x and y on special segments.